Today on Maths is Fun, I want to talk about Fibonacci numbers. You probably remember these from school, but if not, here's a quick refresher. So it's just a sequence of numbers that is derived from adding the last two numbers in the sequence together to get your new number. How does that work? So we start off with the number 1. The last two numbers, well, there's only 1. We add that together, we get 1. Now we have two numbers, 1 and 1 is 2. If we add the last two numbers together, 2 and 1, we get 3. If we add the last two numbers together, 3 and 2, we get 5. 5 and 3 is 8. And 8 and 5 is 13. 13 and 8 is 21. And so on and so forth. You can keep going as long as you like, really. So that's the Fibonacci sequence. But what's really cool about it is that it appears everywhere in the natural world. It's really quite astounding. So, for example, the way X chromosomes are handed down through our parents and grandparents and great-grandparents is in exact replica of the Fibonacci sequence. The way that honeybees recreate is also in the same sequence of Fibonacci numbers. You also can see it illustrated in rabbits, all sorts of things. We also see it in the natural world in terms of flowers. The way that a sunflower arranges its petals is in line with the Fibonacci sequence. And other flowers and plants will grow the same way as well. You can see it in this really, really cool ammonite fossil. Is the Fibonacci sequence at work in nature. And you can also see it in a spiral galaxy. The same sequence, the same pattern is applied. So you can also see it in our DNA, for example. The ratio of the height and width of our DNA is the golden sequence. So from the smallest thing in our universe, which is perhaps our DNA, right up to the largest thing in our observable universe, a spiral galaxy, all adhere to these same rules, which is pretty cool. The other thing about the Fibonacci sequence is if you draw it out, you get the really cool spiral pattern. What do I mean? Let me show you. So we start off with one box. And another one box, and now a box that's twice the size of that, is the 2, and now a box that is 3, and now a box that is 5, and now a box that is 8, and now a box that is 13 in size, and 21, and so on. And then we draw a curve starting at the 1 and going through each box. And we get this beautiful, poorly drawn by me, spiral. And it's that spiral that you see everywhere in nature. It's the exact spiral that you see like on the ammonite that I showed you earlier. It's really cool. Again, no practical application to this in say the business world that I can think of, but a really fascinating look at a simple series of numbers and how this echoes throughout nature and the natural world, showing that maths is really the root of so much of what we